Now the insertion steps are the same, okay? It's just a bit longer because of the edge cases. Assume this is our head node, alright? The next thing you want to do, okay, actually the first thing you want to do, assume I want to insert where 3 is, okay? Usually we went, when we did it in a singly linked list, we inserted where 0, 1, 2, we had to specify the index. You can do it that way, or you can also do a different approach, which is assume I want to insert a node where 3 is. Okay, so this would be regarded as insertion in the middle. So the first step you want to take is that you make a temporary node and you make it equal to head, okay, and then you loop it, okay, along the linked list such that it traverses every single node until it finds the 3. So it's going to check here, there's no 3, then it comes over to this next one and it checks, okay, here's a 3, so I'm going to stop here. Okay, so now T is there. Once that's done, the next thing you want to do is you want to create a new node. I'm going to call this new node N, okay, and I just create this new node like that, and assume the value I want to enter is 9 where the 3. So this is my new node now. After doing that, okay, this I would say is step number 1. Okay, make T loop there, make the new node would be step number 2. Step number 3 is that you're going to say new node's next value should point to T's next value, which is this node right over here. So we link it like that. Perfect. And then you're going to say that the new node's previous value is T. Okay, so that's going to be step number 4. Okay, so this is actually, no, this is step number 3. This is step number 4. Easy peasy. After that, what you want to do is you want to say that this node's previous, alright, this node's previous should equal to this node N. Now how do you access this one? You don't need a temporary variable. You can just say t.next.previous. Okay, that will just reference this node's previous value, and that's gonna point to this here. Now that's gonna be step number 5. Once that's done, you're gonna next say that this N's previous value, actually no, we're done with that. You're gonna say T's next value is going to be equal to N. Alright, so basically we're breaking this link over here, and it's gonna work like this. T is gonna be here, right? This is gonna be our first node. Then if we move to the next, this is gonna be our second node. After that, this N node is gonna be our third node, and then the last node, the tail, is going to be our fourth node. Okay, so we break the link. So this is just like a 5-step process. Okay, so if we come into the code part of this, before we start coding that part, I want you to also take note of the edge cases. Firstly, one edge case is our head can be null, meaning our linked list is empty. And if that's the case, then what you want to do is, of course, you want to return. But before returning, you want to say head is equal to new node, and you're going to put our data inside there. Okay, that's what you want to do. Now, once you've done that, then I don't really think there's many other, there's not really much of an edge case except for the tail, but we can deal with that later. So you can proceed with step number 1. Step number 1 was creating a temporary variable and make it equal to head. Then step number 2 is to loop that using a while loop, and while you're looping it, you need to increment. So it's going to be T is equal to T dot next. And let me just scroll down a bit so you can see better. Okay, T dot next. Now inside this while loop, there's going to be 2 conditions. Okay, this is kind of like an edge case, because one edge case that we haven't covered yet is that you might be inserting at the tail. Okay, which is right over here. You can insert, you can end up ending at the tail, or you can, even once you're looping, you can end up getting a null value. So you have to cover that and capture that in your code. So how do we do that? Firstly, we're going to write the code for our temp not being null. Okay, because we don't want our temp to be null. Okay, because I mean it means that we reach the end of our linked list. Okay, that's one. And then the other condition you want to cover is that you found the element. Okay, so this covers the tail. And now the next one condition where you want to stop looping and incrementing t is if you actually found your element. Okay, remember we had this element inside here. So if our element is in fact equal to this, the element we say that, let me show you the diagram, 3, right? So at the element would be 3, data would be 9, our d would be 9. So we want to check where 3 is. So if we found the node where 3 is, then we want to stop incrementing and we want to get out of the loop. Now the loop terminates on 2 conditions, so we want to clarify when it terminates. So we're going to check if it terminated when our temporary variable was null, basically this condition, and if it is that it terminated because it reached the end of our linked list where temp is null, then you want to see out element not found. Alright, actually put that like that. Alright, and then you want to return, and then you want to also still check if the loop terminated because of our data being found. So you want to check here if t dot data, actually no, you don't need to check for that, that's yeah, you can leave that because that's default. But there is another condition, and you want to check if it reached the last node. And how do you check if it's if we are at the last node? We want to check if t dot next is null, because remember this condition shows that the element does not exist in the linked list. Its temp is null. So basically our t kept incrementing and eventually it became null. However, right here when t dot next is null, it means that t is here, and now it's, if you do t dot next, then it gives you this value. T is a null, t's next value is null. That's what it shows you. So that's what you have to take care of. Okay, this one shows you that we are sitting at the tail, and if that is the case, then you want to do insert at tail, and you want to put d's value there. Okay, and then you can just return. And by the way, I made a mistake here. Because this is a doubly linked list, you cannot just do like that, or maybe you can, but a better approach would be, I'm just going to call the insert at head function here. Okay, and I'm going to put a d there. Done. After that, pretty much all the edge cases are done. We can proceed with our next step, which is step number, actually, yeah, step number 2. Step number 2 was to create a new node called n. Okay, so I'm going to say node n is equal to new node, and I'm going to put my data inside of it. Okay, then we can move on to step number 3, which is that, not step number 3, that the n node's next value should be t's next value. Okay, so I'm going to say n dot next is equal to t dot next. Look, if you don't understand this, I want you to write it on a piece of paper and practice, like dry run it out to draw the diagram, the picture. Then it's going to make sense. Otherwise, I myself just cannot understand by looking at the code. I need this diagram. Okay, so then step number 3, we've done that. Step number 4 is that n dot previous is equal to the tail, or not the tail, is equal to t, right? So n dot previous is equal to t. Step number 5 is that n's, actually no, step number 5 is that t dot this node's next value or previous value, sorry, is going to be equal to n. And how do you access this node? You don't need a temporary node. You can just say t dot next. Okay, so you can say t dot next, right? And you can say now we are at the last node, and then you can say its previous is equal to our n node. Okay, and then of course the last step is this is step number 6. Okay, so temp's next value is equal to n, because remember temp's next value was this node over here, but now we want to make its next value our n. So yeah, that's how you code this out. Thanks for watching.